chain me on the same page. We are effortless, schemaless, living in the future. You and me, made for us, serverless, living in the future of the clouds.
All right. Good morning, good evening, good afternoon, everyone. Let's first do audio check. Can you tell me if you hear me well in the chat, please? Come on, how is the audio? All right, okay, so let's move on. So we are together for this short workshop, 30-minute-ish, maybe up to an hour, but no more. Full about hands-on, very practical. We share a lot of code. We are going over demos, so nothing to do with marketing. I'm a host, Cedrick Lunven. I'm leading the developer relation team at DataStax. I'm also software engineering, implementing some tools like the command line interface, the CLI. Here you see what I'm doing. And if you want to be in touch with me, you have my coordinates, Twitter, LinkedIn, GitHub. Go for it. Invite me. Would be happy to have you in my network. It has been a while, so let's see if I'm not rusty or not. So for today, this 30-minute, we will introduce you to Apache Beam, a way to move the data in and out for the wide range of solutions. There are a lot of connectors out there for this technology. You can run it locally and you can run it on cloud providers. And that's a neat part of it. You can set up things, build your flows, pipeline, and when they are ready for the big show, deploy them to the cloud providers and make them scale super large. So let's get rolling with this Apache Beam solution, actually created by Google, and they are hosting a distributed version of that called Google DataFlow on GCP. I will come back to that later, but it's an open source project from the Apache Foundation. Has been open source, I think 5 years ago. The idea of this tool is really to build some pipelines, so meaning moving data from A to B, both batch flows, so initial loads, and streaming flows. It's, you know, sometimes you can be say a competitor for Spark, Flink, Samza, all kind of things, but actually it's not. It's an abstraction. It's really available in Java and Python, just a couple of classes and implementation. And when you build an asset with that technology, you can actually run it in Spark, running in Flink, or running in Samza or DataFlow. So it's implement it once, run it on multiple runtimes. And I think it will gain some tractions because, you know, if you look at GCP cloud providers, it's DataFlow. If you look into AWS, it's more Spark, Flink. If you go to Azure, it's more Spark. So if you can have the same data pipeline that you can run on multiple cloud providers and also locally, that's what you want to do, something that is portable, shareables. So there are some SDKs, as you can see on the screen: Java, Python, Go, SQL. The two most in use, of course, are Java and Python. lately Python, because with that you can totally do machine learning training. And guess what? I hope I will have time to show you that actually today. So here in the workshop, we are really here to show you what you can do with the DataStax Astra platform. So Cassandra as a service in the cloud, also providing Pulsar with a lot of APIs and functions you can use. So if you look at the bottom of the screen, this is all the different interfaces that you can interact with in Astra. So free to use, super generous free tier, like multiple millions query amounts. And so with that, we want to interact with Beam. So init load, extract, move the data in and out, both from Cassandra and Pulsar. And, you know, no surprise, but actually in the Beam ecosystem, you already have two connectors. The connector is called I/O for input/output. So you have the Pulsar for the streaming, and you have Cassandra I/O for Cassandra. Unfortunately, and it's the case in a lot of, a few solutions, when you want to interact with Cassandra, sometimes the interfaces are not generic enough, and you cannot really interact with Astra, AstraDB. The drivers, the Cassandra drivers, allow to do it, but sometimes, they are building some abstraction layer on top of it. And for Beam, it was the case. Some variables that you need to connect was not available. So part of our work was to create something called AstraDB.io, which is the connector to use this Beam with Astra, simply put. So what we are doing is we are managing the session to get a singleton, to get performance, and we are building stuff to read from Astra. This is called the input, or here on screen you can see AstraDB.read, or you can write into Cassandra Astra with AstraDB.io.write.delete. And we enforce all the best practice, consistency, schemas, mapping that you want to do with Astra. And we also offer a way to execute some SQL. So it's really an improvement from the existing Cassandra I/O. We are improving the performance. And this solution is, of course, open source. All right. It's a short session, and I do not want to do a lot of theory. We are very practical on this channel, so I would like to move as soon as possible to hands-on and, maybe you touching this solution without having to install anything. So here I would like to implement or run in front of you a flow that will load a CSV into Cassandra. Very basic stuff, sure, but at least it shows you how you build a pipeline in Beam using Java, how you set up the parameter, how you execute the thing, and what it looked like in Astra or Cassandra. As usual, you have nothing to install. It's based on Gitpod, but still you can run everything. So if I move now to this view, with on left part, this is the README. So let me copy you the README again in the chat. Here, everything I will do is just step-by-step instruction, and I hope you would do the same. Right? Okay, so here at the beginning, housekeeping, frequent asked question, material for the session. So here, everything is free. We are sharing you the slide. They are in the GitHub repo. You saw the GitHub repo. You can run, you can redo the exercises for free. Okay, there is nothing to no credit card. You really just need a Google account or a GitHub account. And the first things we need to do to put some data in Astra is actually to create an Astra account. So if you don't have any, just click the image and register, sign in with your Google account. Not a lot to discuss here. Just go there and authenticate with your account. So astra.datastax.com and go here. Okay, hope not all the website would be as slow. The reason is probably that I'm sharing and it's a bit hot here, but hey, we are moving on. Okay, so now connected to the UI, you only need one thing in the UI, it's to get credentials. Because we'll interact with the solution only through command line, idea is to be as fast as possible. But to interact with the solution, we need an API key, or also called a token. So here you go to settings, you go to token, and it's written here in step 2 on the README. And you select organization administrator. We want to be the big boss here. Click generate token. And here you got you got the token. And what we really need is so I encourage you to save that file. Because for security reason, it will not be shown to you again. So I will do the same. I'm saving that locally. And any solution SaaS you are using, if they want to comply with the standard of the industry, when a token is generated, it's shown once, and then it's done. You will not be able to show it again through the UI because the provider is not actually aware of what the value is. Okay, so what we really need is actually the token value here. When it's done, we're good. We can do whatever we want on the product. Okay, so here what I'm doing right now is going here and open Gitpod. Gitpod is an IDE in the cloud. So based on VS Code, it's VS Code in the cloud. It will provide us everything we need to code. So not only Java, but also Maven, a tool to build, a tool to run. Also, when the workspace is initializing, we put with a little bit of tips to list what needs to be available in when the workspace starts. Okay, so it's starting. I'll try to close as many things as possible. Okay. Launching. It will give us a terminal. And this is in that terminal that we will actually do the connection in between the IDE and Astra. Okay. So to do so, just doing Astra. And by the way, it's not rocket science. I'm just going over here step 4 and now step 5. So remember, you probably now have your token in the clipboard. So you will paste the token, right? So here I'm doing Astra login -- token. And instead of having that in my clipboard, I tend to have an environment variable ND and always available. So if you are able to log in by pasting your token, you can now do Astra org and see that, hey, you are connected to Astra, you're good to go. Astra DB list if you want to see what are the database that running. Astra streaming list if you want to see your current Pulsar tenant running, and so forth and so on. But it was just Astra login token and you're good to go. And I'm using that because I will initiate all the resources we need pretty quickly now instead of, you know, clicking all the screens. So to move data in the database, hey, we need a database. So to do a database, it will be Astra DB create. Here for the name, I chose as a workshop bin. For the key space, which is like an Oracle schema, I chose Beam. So, you know, with GitHub, you can now copy that command, go here, paste the command. So maybe the first time you paste in Gitpod, you get this warning stating that do you allow any paste? Yeah, let's go enable that. And we are actually creating the database. So again, no worry, it's free to use. Actually, you have 25 bucks of credit monthly. It's renew every month, and that's about 80 million read and write. So that's, you know, you can run small production that without paying anything. So it should take about 1 minute to start. As you can see here, I'm kind of stuck. I'm waiting for the database to be pending to active. But if here on my local machine, I do Astra DB list, I can see that my instance is pending. But here, for the purpose of this workshop, I make sure that the command is blocking, because then we can move forward and we are sure that the database is there. Oh, I saw a comment regarding blurry. Is that me? Okay, let me close that and see if I can. Okay, database is back, ready to go. I can Astra DB list. As you can see, workshop bin is now there. All right, so I can list the database, describe the database, but here what we want to do actually is to immediately create a table. So the table is called Fable with document ID, title, and document. All right, database has been initialized. I can show you the content of the table right away. And of course, it's empty, but at least you know we do have the database and the table. Okay, my bad. Come on, here we go. Okay, database is running, table is ready. Here on the IDE, you have all the code you need to do the Apache Beam pipeline. But you need to set up the local project. And again, we do have an ND command that will set up everything you need. So create a file called .env locally. So you can have a look with the cat command. So here you can see the token, the database region, the database name are available in this file. And so what we want to do is load all those information as environment variable. And because now they are environment variable, I can totally use them in my app. So let's see if I can run the project. So Maven run compile. And that actually the meat of the solution. So here I'm doing a demo. You can come back. Actually, if you watch the recording, you can pause the video and wait for everything to happen in front of you. But here the code is available and you can run that whenever you want. So we will load a CSV. So let me open that CSV. Very basic, 37 rows. Not much, but that's enough to demonstrate what we want, what we can do. Also, soon after this data loading, I will do some embeddings computation for the vector search, and I will use my OpenAD API key. So, I don't need to import thousands and thousands of rows. Okay, so now regarding the code. So that's very important. So when you build something with Apache Beam, you will create something called a pipeline. So here you saw row 55. This is really what you want to do, a pipeline. This pipeline needs some inputs, some parameters. Those parameters are defined in something called an option. So here you have pipeline option factory that will provide you a pipeline option. And this is your job when you build a pipeline to create an object, actually an interface, that will extend the option and provide the parameter you need. So here, if we want to move some CSV into Astra, we will need everything to Astra, which is a token, the database name, the key space, the table where you want to write, and for the CSV, is the CSV path, the input of the CSV. I don't know if I can uncompile this guy. Yes, I can. So here in Astra DB read, I provide a table, and if I keep moving in the hierarchy, here I can see that I will have to provide something called Astra token, Astra secure bundle, which is the archive to initiate some connectivity in between you and Astra. Okay. All right. So let's run that guy. So to run it, as you can see, it's just a main. Nothing special about it. It's a main where you define your option, you initialize your pipeline, and the pipeline will be a succession of steps. First steps is always a read. You need to get the data from something. Then doing some transformation or multiple transformation, you can split and then going back into the write at the end of the pipeline. So what is very important to understand is all the objects that are, all the inputs that are used in the pipeline, all the items are immutable and they will be distributed across multiple threads. So when you read something, the input and the processing of the output will be multi-threaded. And what you can do in your machine with 8 to 10 threads, when you deploy that in the cloud, you can have hundreds or even thousands of threads doing the work. So it's a way to burst the performance and to do some initial loading. You can easily validate that it's working with a few threads, and when you're ready, deploy on a stronger platform and get gigabyte of data loaded super quickly. It's scalable vertically and horizontally. So here what I'm doing, loading the CSV, converting each row of the CSV as an object called Fable DTO, which is the object mapping for my favorite table, and then simply write. So here I copy. And it seems like I need the cloud secure bundle, and actually this cloud secure bundle has been already downloaded when I created the .env file. So pretty handy. I simply need to be in the proper folder and run that guy. So in the meantime, I will go to another and I do Astra, DB, SQLSH, just to connect to the database. I think it's workshop Beam, and we use the keyspace Beam. Okay, so I will let the first terminal, okay, build finish. So if now I go to SQLSH and see the contents of my table Fable, and no surprise, it's now populated. Very simple, right? You have a sample class to just reuse to move some CSV to Astra. Yeah, super simple. Now validated the data. Okay, we've done that. So here again, as a gift, second flow implemented for you is actually doing some computation of the embeddings. So now Astra is really focused on vector store, vector search, and all the generative AI use case you want to implement. And to be able to do some search and, like content generation, like a ChatGPT or chatbot, on your own data, you need to vectorize. You need to build the embeddings of your own data. To do so, you are using an embeddings API. And here in that demo, I'm using OpenAI embeddings API, and I'm using my own OpenAI ID key. So if you have one, simply provide it. If not, just look at what I'm doing. It's unfortunately OpenAI, it's not free to use, so cannot really give you here a key. So my OpenAPI key should be already defined as an environment variable in the same way as the token a few minutes before. And if I open this second flow, second pipeline, not a lot of difference. It's still a single class, single main. I will create an option. So this time the option will take my API key as input and is working on the table. So this flow will stay in the same table with this API key. What is doing? Well, read all the items from the table, alter the table to create some vector column, alter the table to create an index, and then row after row, invoke the OpenAI API to build the vector and write the result in the new created column. So if you are looking about the different article out there, you see a lot of people explaining how to use LangChain, and LangChain will do a lot of generation and chatbot and agent for you. But it's always started with, you already have your data and you already have your vector database ready to go. And then you ask the question, how do I have my database ready to go? Yeah, this kind of solution would be handy to vectorize your data, to build the data. LangChain can also do that with some transformers. But hey, the neat part here is this transformer can scale vertically and horizontally the same way we did to load the CSV. And here I can probably just copy that and see if everything is ready, if I'm in the proper folder. And let's see what I got. So you can see in the logs that it's actually executing the different alter table to create the new needed column, the new column need metadata. And if now I go to my SQLSH and describe the table fable, so first things to understand is now we do have new columns. We do have the vector column, we do have the metadata column. And this table is built actually to comply with our open source framework called Cas.io. And Cas.io is the glue, open source as well, based in Python, is the glue you will, it's the glue to use all the data we just created directly with LangChain. So way more sexy than just moving some CSV, I guess, right? Now, if I want to show you the content of that table, maybe limit 1 because the vector is pretty long. So the length of the vector is really depending on the model you are using and the provider you are using. So here I'm using OpenAI, you know that. And here I'm using the model called Text Embedding ADA 002, which is 1536 length. For some reason, they are all the same. Yeah, they are all multiple of this guy. So for audio, I've seen 2072, also 768. It's such like that. Okay, so now you have a second flow running, doing some embeddings. The code is there. The code is for you. Use it. Now, what about Google? Well, actually, the same features, the same framework with the same classes can be used to build some flows and run that flows in hosted version of Beam in Google called DataFlow. So here, if you go to sample DataFlow and you open the flow, you will see that it's also a Beam pipeline extending options. And because it's running in GCP, you have this GCP option, and the GCP option actually asks you to provide the GCP option, which are the project ID, where you want to run that, the region, your credentials, all the inputs needed to run in Google actually. And here you can see that I've listed step by step how you can create a Google project and run the flow. GCP, even if there is a free tier and $300 of credit for free, you still need to provide the credit card. So not something you actually touch in one of our workshops. You need to do this registration first. But still, I can show you what we have been doing. So if you need to load some files, you will probably use the object store of Google, which is Google Cloud Storage, GCS, which is the equivalent of S3 in AWS. And this is where you will put your files in something called buckets. It's slow. Okay. Maybe I can directly show you some data flow. Okay, it's coming. It's taking a while. So here I put some bucket called Astra data flow input, and this is what I provide in my flow, just to say, hey, when you need to read a CSV and import to Astra, use from this bucket. But the flow that you got actually is not just moving CSV to Astra. It's actually doing the opposite. It's moving data from Astra to something else. What could be the something else? Well, multiple databases in GCP, and Beam provide you all the IO you need to connect to BigQuery, to connect to Bigtable, to connect to any relational database, Spanner. Here in the code I provide you, it's BigQuery, and it's taking forever to load. The code will actually create you something called a dataset, which is a folder in BigQuery where you want to save that. And it will create you a table, which is the same name as the table in Astra. Okay, integration. Let's see if I can actually show you some code. It's taking forever. It's only 34. Okay, DataFlow. Okay, let's go. So this is our Beam key space. Okay, and here's some sample of table that have been moved, actually copied from Astra into BigQuery. So it could be the same flow and you're changing just input and output and a little bit of mapping. It is as easy as that. And Beam will distribute the load even on multiple machine and multiple thread. And it can do that because everything is working on is immutable and the granularity is really just the item. So one item can be totally processed on one instance without never having to communicate to others. So it's fully distributed and as stateless as possible for that to be super fast. So one of our customers actually achieved more than 120K operation per second. So pretty cool. And you do have the code available to you. Now, so that's actually BigQuery. Now, if I really need to show you what a DataFlow look like. So when you run, so if I go to the very end of the README, when you run, your flow, the default flow is actually default flow is really local. But if you say runner DataFlow and provide the GCP project ID, Beam itself know that it will deploy your flows into DataFlow in that project. So as long as you do have the credentials, it's going there. And you see your pipeline showing up here. Actually, all the code and dependencies are loaded in Google Cloud Storage in a staging bucket. And here you have access to the flows and see actually what happened in your flows like that. You can see something that you don't have locally. Obviously, this is the kind of enterprise version of that. And as you can see, we did a select from Astra, and the select has been split in multiple chunks for each chunk to be processed independently and simultaneously. And so here you can see the log that, for instance, 23 split has been processed. Even if you do select star from a table to just move, the connector will do something called a range query. It will distribute the read into Cassandra partition efficiently to process block of the same partition on the same Beam thread to be as fast as possible. So with that, it's like Beam is partition aware. It does not have to run on the same machine and still is able to process rows coming in the same partition on the same machine and avoid some moving the data across the machine. So it's immutable and stateless again. Okay, so I've shown you GCS, DataFlow, BigQuery. And again, I gave you the code, I gave you the documentation and the step-by-step instruction, but you will need a Google account. Beam is not the only tutorial or the only tool that we are integrating with Astra. Actually, if you go to awesomeastra.github.io, here you will see more than, now I think, more than 40 for sure, but almost 50 different tools that you can integrate with Astra. So all the all the tools like data grip, like all the studio, and if you go manage data and all the processing framework, here everything is written for you to connect. If you want to use Grafana, if you want to use Presto, MindDB, dbeaver, here really step-by-step instruction how to do so. So that's really client-side data navigation, but we also have the same for tooling. So today I show you Beam, but we have the same for Flink, Airflow, NiFi, Spark, Celery, Google Cloud Function, and so forth and so on. So there are a lot out there. So if you're interested, look at the interface you're interested in, navigate. And if you do not find what you need, just contact us and we can prioritize this kind of integration. We are really working on making Astra available on as broad technology as possible. Okay, so we did the lab. That's okay. That's the support slide to do the embeddings. That's the screen for the embeddings. The runner, that's a reminder. This is all the location you can run your Beam pipeline. So it's not Beam against the rest of the world. Is implemented once, coping with the Beam interface, and be able to run in a lot of different technology. So Google Cloud, and that's the second Astra to BigQuery. So now to close that, we did a lot of flows to integrate with Google internally, and we saw a need for kind of a template. So now when you go to the DataFlow UI and you want to like create a new job, you can create a new job from a function, like create job from a template. So here you go to template, and actually you say moving Astra, and here you have a few templates available to check. And so the code is there. Soon you will see Astra available here just to move data from Astra to something else directly on the user interface. Okay, right. Let's see if I can just show you a custom, but we are at the end. So I will probably stop here. Just can I see my file and see if I can actually have access to that or not. Nope, I don't find that here. I do have the bucket for sure, but is the bucket enough? I don't think so. So yeah, custom template. Yeah, anyway, it's super slow. So I will stop there for sake of the time. But here, as you can see, with this solution, you can move data, but not only, you can totally do some computation and even heavy computation, interacting with third parties like generative AI and OpenAI we did today. And hopefully we will integrate that more deeply with Astra soon. But before then, stay in touch with us, either on Discord, on Academy to learn more about Cassandra, and to know what are the workshops coming. Subscribe to the channel, that's a way to do it. Get notified if you ring that bell, or go to datastax.com/workshop and see the recording of previous session and what's coming. And we are also on YouTube, so follow us, and we will also poke as soon as we have new content to share. And with that, I'm obviously and totally expected out of time, but that's okay. So have a great end of day, and